You have a bag that contains 1,000 coins. 999 of them are fair, and one of them is a trick coin. That trick coin has heads on both sides. You pick a coin from this bag at random. So you reach in, you grab a coin, and you flip it 10 times. Every single time you flip that coin, it came up as heads. What is the probability that you've chosen the trick coin? So I'm going to start by defining some events. E is the event. Let's call this the event we have the trick coin. And F, well, F, you wouldn't want to say F is the event that I have a fair coin, because that would actually just be E complement. F would be the event that we got that we could get 10 heads. So we can figure out the probability of getting the trick coin. Without anything else, we know there's 1,000 coins total, right? And only one of them is the trick coin. So the probability of getting the trick coin is 1 in 1,000. That's pretty easy. And thus you could figure out the probability of E complement. I'm not going to bother with that, though. However, we couldn't really figure out just the raw probability of F, or at least not easily. So instead of looking at the probability of F, could I figure out what is the probability of F given E? What is the probability of getting 10 heads in a row, given that I have a trick coin? I just realized I misspelled trick. If I have the trick coin, what's the probability that I get 10 heads in a row? Well, if I have heads on both sides, every time I flip it, it's going to be heads. So that's 100%. That's a 1. The probability of F given E is 1. Similarly, the probability of F given E complement, we could figure this out. If I had something that's not the trick coin, what is the probability of getting 10 heads in a row? Well, each coin flip is independent of one another, and so to find the probability of getting 10 flips in a row, that would just be 1/2 times 1/2 times 1/2 times 1/2, and so on. This actually comes out as 1 over 1,024. If we were to take 2 to the 10th, that's 1,024. So we are being asked to find what is the probability that we have the trick coin given that it came up 10 times in a row. What is E given F? You'll notice the probabilities, the conditional probabilities we were able to determine on this one were both F given E. This is F given E complement. We're looking for E given F. So this is how we know that we're dealing with a Bayes' theorem problem. All right, so we are able to, given the pieces of information we have, we know the probability of E is 1 out of 1,000. And thus the probability of E complement down here would be 999 out of 1,000. Okay. If we have a trick coin, we know the probability of F given E would be 1. And thus the probability of not getting 10 coins in a row, 10 heads in a row rather, would be 0. You could just leave that branch off if you wanted, I suppose, since it does just have a probability of 0. Alright, the probability of F given E complement here would be 1 over 1,024, and this would, the probability of F complement given E complement would be 1,023 out of 1,024. We probably don't need that. Usually when we're writing up this sort of stuff, we can focus on just the positive. So, oftentimes you don't need the F complement or the negative versions of these. Sometimes you do, but all right. So that's our tree diagram. What is the probability? We can actually figure out what is the probability of F, just in general. So not knowing anything about whether or not it's a trick coin, if we reach in there, grab a coin, and flip it 10 times in a row, what is the probability it comes up 10 times? Knowing that there is this trick coin in there, we may or may not have it, though. Well, let's see. 1,000 times 1 is 1,000th. 999 over 1,000 is 999 over 999 over 1,000 times 1 over 1,024, that is. 1,024,000. And this one, like I said, I'm not going to write that down unless I actually need it. So right now I'm looking for the probability of F because I'm trying to find the probability of, let me show you why I'm trying to do that. I'm trying to find the probability of E intersect F divided by the probability of f. This is my generic conditional probability. The probability of E given f is the probability of the intersection divided by the probability of the condition here. So let's see. Probability of E intersect f was this one up here. That's 1 over 1,000. The probability of f is going to be the sum of these. That's my law of total probability right there. And I think this is something that probably would be deserved to just type into a calculator. So let me go ahead and, well, first off, 1 over 1,000, let me just point out, that's 0.001. It's easier to type as 0.001. So I'm going to do 0.001 divided by parentheses 0.001 plus 999 over 1024000. So I know that division is going to happen before the addition inside the parentheses because of the order of operations, and you can see there's pretty darn close to a 50% chance. Equals approximately 0.5062. Just slightly more likely than not to have the trick coin. So you may be wondering why in the world is that? Well, this one, like I said, is 0.001. This number right here, if I was to actually write that down as a decimal, 999 divided by 1024000 is, that's really close to 0.001. 0.00975586. That's really close to 0.00. Oops, I missed a 0. There we go. Yeah, that's really close to 0.001. So if you were to repeat this experiment a bunch of times, roughly 0.1% of the time you would have the trick coin, and that's why you'd be able to get all 10 in a row. Another roughly 0.1% of the time you'd have one of the non-trick coins, and you've just been flipping it enough that you would actually get all 10 in a row.